Hello everyone. Good morning. Am I audible and perfectly visible to you? And also my screen is visible to all of you. Right in chat box. Am I audible and perfectly visible? Okay. Very good. Awesome. Hello, everyone. Okay. So uh, hope all are doing good and इसका preparation अच्छे से चल रहा है. So with same pace, we will start in today class the communication system. Okay. So in this class, they will discuss how we can transfer the signal from one place to another place, and what are the parameters required to define the range of the signal transmitter, and how we can like transfer the signal like low frequency signal, how we can modify them, and how we can uh, uh, amplify the signals. Okay, so in this class, we will cover all the topics. Along with, we will also discuss in this class like how the signal transfer from like Earth to like you can say space by using the electromagnetic waves, radio waves, and microwaves, all these things. So we will discuss all these things in this class. Okay. So with same pace and with good note, and we will start the class. So now, as you can see on, as you can see here, so these are the main function of today class. First, we will discuss the what is the communication system and the how we can communicate by using the analog and the analog signals and the digital signals. How we can convert the analogous signals into like the digital signals, and after that we will discuss how the like sound and like mechanical signals is converted into electrical signals. Okay. After that, we will discuss how we can propagate the signals in form of the EM radiation. And after that, we will discuss modulation of the signal. Okay. Uh, So, as you can see here, these are some types of the communication system. Like, uh, as I am speaking in front of you, like I am making some sound wave, and this sound wave is converted into the electrical signals by using a microphone. And microphone converted these signals into electrical signals. These electrical signals are transferred by the computer in the form of the like uh, data signals that is transferred in your mobile phone and the laptops also in the form of the internet. Okay. So this type of method we can transfer the signals, and usually we are transferring the signals in mechanical signal into by converting into electrical signals. Okay. So first on the nature of the information, the speech transmission can be done in form of the radio signals, picture transmission in terms of the television signal, telecasting signal TV, and the facilium signal, that is the fax. As you already know, we can transfer the one document by using the fax, and data transmission in the form of the internet as you are using in your mobile phone, and data is transferring. In data transmission, all picture transmission and the fax transmission, all the detail can be done by the internet transmission. Okay. On the basis of the signals transmitted, the communication system is like an analogous communication system and the digital communication system. Okay, as you can see here, uh, here it is the analogous digital signals and the uh, analogous digital and digital signals. And on the basis of the transmission channel, like line, wire to wire, line communication, there are two wire transmitter, like transmitter and the receiver, both are connected with some wire. And we can say two wire transmission lines, coaxial cables, optical fiber, space communication. These are the basic fundament of communication system when we are having transmission channel. Okay. Now on the basis of the modulation, like if we are having analogous signal, then the continuous wave modulation we will have amplitude modulation. In continuous wave modulation, there will be amplitude modulation, phase modulation, and the frequency modulation. Now pulse modulation, if we are not having a continuous wave, we are having some in form of discrete. In that case, the pulse modulation will take place here. In that case, the pulse modulation will be take place here. And you can see here in pulse modulation, there is some PAM, PTM, PCM, and PPM. These are like pulse amplitude modulation. First will be pulse modulation amplitude, pulse amplitude modulation. Second will be the PPM, that will be pulse position. In this case, we are having some like uh, temporal modulation. In that case, the phase position also is changing and the width of modulation. In this case, PWM, that will be pulse width modulation. Pulse position modulation, that will be the PPM, and the PCM will be pulse code modulation. So in your syllabus, only these continuous wave modulation, amplitude modulation, frequency phase modulation is given. So we will discuss these modulation in detail. Pulse modulation is not so much in your syllabus at the order, and in NEET also very few question is asked from the pulse modulation. Okay, so we will discuss mainly the modulation based on the amplitude modulation and the frequency modulation sometimes. Okay, so now in this case, elements of the communication system. What will be the elements and how the communication or the signals is transmitted from one system to another system. Like for first, we are having information source. Information source means the message is originated. We can say as I'm saying, like I am talking with you. I'm producing some sound. It means I am the source of the information, and I am the source of the information. I am generating the message signal. These messaging signal we transfer to the transmitter. This transmitter transmit the signal. This transmitter, this transmitter will transmit the signals by using the channel. It is transferring the signal, and then the transmitter signals can also be done by the wires and the line transmission also. And these signals transfer to the channel. Channel what will do? Channel will support the signal to transmit it directly to the receiver, and receiver receives the signal. Receiver receives the signals and it converted into message signal, and we will use as the information. Okay. Sometime what happens when the signal is transmitted during the channel, some noise will also occur because of the pressure difference, temperature difference, and some other factor also. Okay. Because of that, we are having some distortion in our actual signal. For that, we are having like optical fiber. In that case, we are having very low noise and very low distortion in the signal. Okay, so I hope this is clear. So the three main fundament, that first will be transmitter and the medium or channel. We can say medium, like if I'm having a mobile phone and I generated some signals and I'm transferring the signal to another mobile phone. In that case, the medium will be air or vacuum. In that case, the channel will be medium or vacuum. Now the received signal will receive it to receiver, and we convert into message signal and we use as the information. Okay. So there are some terminology that here I use: transmitter, channel, receiver, and another will be repeater, and what will be modulator. So we will discuss these in one by one. First is the transducer. Transducer is the device that converts one form of energy into another form. It means transducer means it converting the energy from one form to another. As I'm speaking, I'm producing the sound wave, and transducer will be microphone that is converted over sound wave into electrical signal. So that will be transducer. See, these definitions are directly asked in your NEET examination, like ascertain and decertain. In that case, the reason also there. In that case, if some statement is written, like transducer is a device that converts one form of energy into another form, and reason like sound wave converted into electrical signal. Microphone convert the sound wave into electrical signal. That we can say is as transducer. Okay. So now the next thing is the transmitter. A transmitter process incoming message signal message net to make suitable transmission through a channel and substitute receptor. Means it transmitter the main functioning is like it is transfer the signal from transmitter to receiver by using the channel, through the channel. Next, receiver will receive the signal directly from the transmitter. Okay, or you can say source as a channel's output. First, transmit the signal that we transferred by using the channel, and after the channel it gives us output. That output is received by the receiver. Okay. Next is attenuation. Attenuation means, as I already mentioned, attenuation and distortion both are look same, and it is a loss of strength of the signal. Strength means if I'm having signals of 50 hertz frequency, that is a very low frequency, you know. Like if I am having frequency, like I am producing a signal that having megahertz frequency, and because of the attenuation, we are not giving like if I'm producing 100 hertz, 100 megahertz frequency, then because of the attenuation, because of the distortion, we are not getting exactly 100 hertz, 100 megahertz frequency. We will get less because of the attenuation. Okay, it means like kind of the damping of the oscillation, you can say also. As you already studied, like simple harmonic motion which is having no attenuation, no energy loss. In damped harmonic oscillation, what happens? The energy is lost, energy is decayed by exponential factor. Same in this case, signals also decaying. We are getting signals with very low strength. Okay, now these are the to overcome this attenuation, what we will do, we will modulate the signal, we will amplify the signal. Modulate means if we are having very low frequency signal, then what we will do, we will amplify the or modulate the signal by superimposing with higher frequency signal. Okay, we will discuss this modulation in very detail. And demodulation means if I having signal that is modulated, mean actual signal having low frequency, but I modulated with a high frequency. Then to extract that low frequency signal, we need to demodulate the signal. That is known as a demodulation. Okay. So at receiver, we will do this process. Repeater mean like if I'm transferring the signal for a very long range, then what I will do, I just produce a signal that is only can transfer at this point. What I need to do, I want to find the signal at this point. Like I am having point A, I am having point B, and I am having point C. In this case, the only the strength can be done by this B point. For to transmit this C point, what I need to do, I need to put another signal that will be this repeater that repeat the signal that transfer to here. And after again, I am having this antenna that will repeat the signal. Now, by introducing number of antennas, I can repeat the signal and I can transfer the signal for a very long range. This is the process, for, work of the repeater that repeat the signal and transfer by antenna to very long range. This will be the very basic fundament of these terminology. Now, till now, if you have any doubt, let me know. You can write in also chat box. Any doubt if you have? Okay, awesome. Most of are getting corrected. Most of are getting. Okay. Now, see, to transfer the signal and how the which bandwidth required to transfer the successfully the signal, that will be bandwidth for the signal. First, I will discuss the analogous signals के लिए क्या bandwidth होगा. Like what will be the bandwidth for the analog signal? See, in this case, if for speech, like some sound wave, in that case, frequency range must be ranges from 300 to 3100. 300 to 3100. In that case, the bandwidth will be 2800 hertz. See, I am using here hertz. Hertz means frequency only, and omega will be 2 pi f. In case if you are getting radian per second, then that will be omega, not this frequency. Okay, here it is only the frequency, not angular frequency. So do not confuse with that. Like hertz mean omega. No, it will be f, or sometime it is also denoted by the n also, NEET also. Now for the music, high frequency produced by the musical instrument, that is audible range, that will be 20 hertz to 20 kilohertz. And within this range, we can only able to hear the sound. If we are going above the 20 kilohertz, then we are not able to hear the complete sound. That will be bandwidth required, this 20 hertz, 20 kilohertz. Now, for the picture and the TV signal transmission, in that case, both will be there, like music transfer, music and the picture. In that case, contain both voice and the picture, and the frequency bandwidth range will be 4.2 to 4.2 megahertz to 6 megahertz. Why I'm telling you these data? Because in NEET, directly these data is asked. What is the frequency range for the musical devices? Okay. And another thing, what is the telecasting? What the bandwidth required? These are directly question is asking on NEET. Okay. So take a screenshot of this. Take a screenshot of this. Okay. Now we can proceed for next. See. Bandwidth of transmission medium. Matlab, in transmission medium, what will bandwidth required? Like if we are having wire communication, in that case, most commonly use the cable is the coaxial cable. Mean coaxial cable in that are like coaxial cable will be used for the wire communication. Okay, in that case, the frequency range will be equal to 750 megahertz. That will also bandwidth. Remark normally operated below 18 gigahertz. Okay, and in free space, we are using the radio waves. Radio waves having the frequency range few hundred kilohertz to gigahertz. Mean in like in exam, it is asked like for the radio wave transmission, the which range of the frequency is required. Like in question, it is given like 20 kilohertz to 1 gigahertz. This is range is given to you in option. Then you need to use this expression as will be radio wave. Okay, radio waves will be having few hundred kilohertz. So there will be 100 kilohertz. Then 100 kilohertz, or you can say 200, 300 kilohertz. In that case, this option will be correct. That is, so radio wave will be correct. Now, see the standard amplitude modulation broadcasting. In that case, the frequency range will be 540 kilohertz to 1600 kilohertz. And for the FM, this like in NEET, this question is asked like for the FM waves, which frequency is range is used? That will be 88 to 108 megahertz. Okay, so this is the very important frequency range that is asked in NEET exam. Okay, now in television, then these four type of frequency is used. First is used for very high frequency. Okay, second, like very high frequency. Sorry, this is the 54 to 72 megahertz and 76 to 88 megahertz. Another will be this 174 to 270. If you are having in option all four ranges, then that will be television. Okay, television broadcasting form में that frequency range are used. Okay, now the cellular mobile in like cellular mobile, if we are having like some calling system and all these things, in that case, this frequency is required. Like mobile to base station. To mobile to base station, we use this 896 to 901 megahertz frequency. If we are having base station to mobile, which means mobile to base station and base station to mobile, then we will have 840 to 935 megahertz frequency. Now for the satellite communication, in satellite communication, we use very high frequency signal that will be ranges from 5 or you can say 6 to this is if I like if I round off this, then I will get 6 gigahertz to 6.4 gigahertz. That range of the satellite communication of the frequency. And also 3.7 to this 4.2. If I have an uplinking and this downlinking, 3.7 to 4.2 downlinking have very less frequency range as compared to this uplink. Okay, now optical communication system. In optical communication system, we using the fiber, we are having this microwave and the ultraviolet regions frequency, terahertz and this terahertz also. In this case, like one signal's optical fibers offers bandwidth greater than the 100 gigahertz. Okay, that's why optical fibers are used for the better signal transfer without any attenuation and the distortion. Okay, very distortion will be there, but very low as compared to the wired coaxial cable communication. Okay. Now see, till now in this table, if you have any doubt, let me know. Take a screenshot of this and please try to remember these frequency ranges, because in NEET directly the question is asked on the basis of these frequency ranges. And we will solve one or two problem based on this frequency range. We take a screenshot of this. Okay, very good. Awesome. Now we will see how we are transmitting the signal from one form to another form. Okay, like as I already said, first we need a transmitter that transmit the signal, and the transducer also to convert the signal from one energy to another form. First, like here is a transmitter. You can see here, as you can see, here is a transmitter. Here it is transmitter. Transmit the antenna, and here is the receiver antenna. Okay, from this point to from this point to from 1 minute from this point to this receiver antenna point, we have this type of signal transmitter. We can say propagation. First, the direct loss wave, space wave. Direct LOS. LOS will be line of sight. Direct line of sight wave, that will be space wave. This travels in only space. Okay, or you can say environmental. Now, this ground reflected wave, that will traverse into the ground. Okay, surface wave, we can also say it as a surface wave. These are the ground wave. Now, the wave, that is the, this is the space wave. For the long range signal transmission, we are having the sky wave. And we will also see what frequency range will be required for these ground reflected wave, sky wave. And if the signal is transmitting like uh, above the earth surface, that is very high altitude, and for the long range we are having like another high frequency range that will be discussed in next slide. Now you can also see here, like for the ground to ground signal transmission, we are having ground to ground. And like line of sight, if we are having like this is that transmitter signal, and we are having like one very high altitude to transfer the signal, then the line of sight will be there. One receiver will be there inside this aeroplane, and this transmit the signal from this point to this point. And the for the line of sight, another case, we are having long range signal transmission. If we are having long range signal transmission, then we are having this like satellite, like you can say, that will be the radio wave for the long signal transmission. Okay, in that case, what happens, we need to transfer, we need to the increase uh, the height of the antennas. And and you will also see the how we can increase the height, and the how range is depending on the height of the antenna. Okay, and okay, now for space wave, we are saying the satellite communication. In that case, we are sending the signal from this one transmitter to this receiver, and that will repeat the signal or amplify the signal and will send towards the receiver. Now this will be act as the channel also. Okay, channel and the repeater also. Okay, these are the, and ionosphere we will have different frequency range. I will discuss this in next slide. Now you can see here, like for the atmospheric stratum layers, in that case, this is the ionosphere. And ionosphere and this all and atmosphere, we are having different layers. Like first will be troposphere. In that case, height over the earth is 10 kilometers, and exiting the day and night both in that case frequency will be very high frequency, up to several gigahertz. Okay, for the transmitter signal through the troposphere, we need to have very high gigahertz frequency. Okay. Now ionosphere, that will be ionosphere having like D, E, F, and F2 layers. In that case, first will be the stratosphere layer, that will be above the 65 to 75 kilometer from the surface of the earth, and exist during the day only. and it reflects the uh, LF and the absorbed MF, high frequency, low frequency, and the moderate. Now you can say, you can also see here, like for the E part, that will be stratosphere. Stratosphere is the part. In that case, its height will be 100 kilometer from the surface of the Earth. That it will be also well visible in and exit only day on. Okay, that helps the surface wave and the reflect high frequency. Okay. Now F1 is a part of the mesosphere. That is very high as compared to this stratospheric part E that is located from the Earth's surface is 170 to 190 kilometers. That will be exit during the daytime, merge up to at a night. This is merge with this thermosphere. Mesosphere will merge in thermosphere during the night time, day and night. Okay, this absorb the high frequency waves and allowing the F2 efficiency reflect HF. See these type of these not asked in question, only this height and the which kind of frequency is required for the which range required for the transmission of the signal. This type of question is asked, so you can remember this height also, and exiting time you can also remember. Uh, but now this range is very important. Now you can see here, this is the range, that is the sky wave. This is asked in your NEET exam. Like, what is the range of the frequency of sky wave? That is 2 megahertz to 30 megahertz. That is asked in your NEET exam. Okay. Space wave are radio waves of very high frequency between 30 megahertz to 300 megahertz, and it can be more of them. If you are having this frequency range, then you can directly say space waves or radio waves with very high frequency. Okay, so you can take a screenshot of this also. Take a screenshot of this, then we will proceed. Okay, till now, if you have any doubt, then write in chat box. You can write in chat box. Oh, oh, sir. I hope all taken the screenshot. Please try to remember these frequency ranges here. Now, okay, now the main part of this lecture is started. So please focus here, everyone. Now we will define the how the line of sight and the maximum range of the antenna at which the signal can be transmitted by the a transmitter, or you can say antenna, and the how much range required to receive the signal and to set the location of the receiver. So you can see here, if I'm having the height of antenna, the height of antenna, the height of this antenna from the ground surface, from the ground surface, from the ground surface, like this is the height of this transmitted antenna from the ground surface. Now you can see here, if I'm having the center of the earth, that will be radius of this earth with that maximum time we are taking that 6400 kilometers. Now you can see the height of antenna is written in this form, like dt equal to root 2 r hp. So this is the range, or you can say line of sight of this antenna. Okay, r will be the radius of this earth, and s is the height of the antenna. Okay. St will be the height of the antenna. Okay, in some time the question is asked like what will be the height of the antenna required if antenna having the power, or you can say range to transmit the signal from, like if it is given in question like the range of the signal transmission is 200 meters, and what will be height of the antenna, what will be height of this transmitted antenna. And sometimes it is also asked like height of the antenna is given to you, then you need to find the range, and the how much far the signal can be transmitted. And you can see from this expression, T is directly proportional to the height. You can see from here directly, this is proportional to height of the antenna. If T is increased, then we need to increase the height as a square root of this function. Like if I am taking the ht equal to t square, if height is increased, then the range is increased as the t square form. Okay. Okay. Now you can write down this formula. That will be ht will be the height of the antenna. Okay. Write down this formula. This formula is very important. 2-3 question is asked in your NEET exam from this formula. Okay. Now the maximum distance between the antenna and the receiver. Okay, between the two antenna, we can say first will be the transmitter and the second will be receiver. The distance will be in between these two these two transmitter and this receiver. That will be like from here. This is from till this point. The range will be, I can say, this will be the transmitter range and this will be the receiver range. Receiver range. In that case, what will be the maximum distance? Or you can say maximum range or distance between the antenna and the receiver to having like line of sight, that will be D transmitter and D receiver. In that case, this will be the distance or you can say line of sight of this transmitter and this will be the line of sight of this receiver. Okay, this will be the uh, maximum line of sight between the antenna, one transmitter and the antenna, or sometimes it is also like what is the maximum line of sight between the two antenna. Okay, so write down this formula here. Write down this also. Okay, in this case, same like if range is given to you and one of the system's height is asked, like in question it is given this antenna is having 100-meter height, transmitter antenna having 100-meter height, and range between or you can say line of sight is given you 20 kilometer. Then you need to find what will be the height of this receiver antenna. You need to you need to have to find this antenna receiver height. So you can find by using this expression. Okay. Now, okay, write down this formula. Then I will proceed with that. I hope all you taken the screenshot of this formula also. Now, we will discuss the modulation of the signal. Okay. In modulation of the signals, what we are having one carrier wave that carries the signal, and another will be message wave. In that way, we are having message that will also known as the baseband signal, and both will be modulated by the modulator, and we are getting output as the modulator signal. That will, in this case, we are having only the amplitude modulator signals. Okay, amplitude modulated signal. Now, if this is the message wave, or you can say baseband signal, and this is the expression for this carrier wave. Then the modulated signal CMT can be written as the superposition of this message signal and this carrier wave signal. In this case, you can see here, this is the expression for this modulated signal. Here we are having only amplitude modulation. Okay, so now you can also separate this as if we take the AC as the common. AC here is the magnitude of this carrier wave, and AM is the magnitude of, you can say magnitude or you can say amplitude. Magnitude, why I'm saying and magnitude here, because it's a numerical value of this message signal, or you can say peak to peak value of this message signal. In this case, this will also the peak to peak value of this carrier wave signal. If I'm taking AC as the common, then here I will get AM and AC, and here will be sine of omega mt, and this is the sine omega c mt. This is the another expression that is very important here, because the question is asked from this expression. In a question, it is given you like, if a carrier wave having frequency 50 hertz and the message wave having frequency 100 hertz, in that case, you need to find the modulated wave expression. Okay. So in this case, this expression, that is the expression that is used here, this AM over AC will be the modulation index. Modulation, this will be modulation index. Okay. So this will be the modulation index, and it is denoted by mu. If I am applying here, then the CMT, that will be modulated wave, will be equal to AC and 1 plus mu sine omega mt, and this will be equal to sine omega c. This is the expression of this modulated wave in terms of the modulation index. Okay. So write down these expression. Write down these expression. Majorly. Okay. Okay. Shall we proceed ahead? Now, if I expand this formula, CMT, that will be equal to AC. See, I am expanding this formula. AC sine omega CT and this all this thing. AC, this will be sine omega CT plus AC and mu, that will be sine omega MT and sine omega CT. Now you can see here, this is the carrier wave and this is the superimposed wave, the omega mt and this omega ct. Now I can again write this as omega ct plus this AC. What you know, sine A, I also know this is the sine A. Sine B can be written as the cos A minus B, A minus B, and plus cos A. Here we will have minus sign also, minus sign also. Here will be minus. Okay. In that case, what will be this expression that will be sine? Because I'm writing directly here, can, by using this expression, that will be cos will be equal to omega c minus omega m, or you can also write omega m minus omega c. That will not change our function value, because in cos minus theta equal to directly cos theta. We can also write this thing. So that will be minus of this AC mu, that will be equal to cos omega m plus omega c and t. You can see here, we are having three type of frequency. We are having three type of frequency. And this expression also can also be written as in terms of this like sine omega ct. I can also write this as, because in books sometimes it is also written as cos omega n omega c t plus AC mu cos omega m plus omega m. Okay. So this will be the expression of this like, but maximum time I recommend you use this expression. Use this expression, that is the uh, used to solve the frequency bandwidth problem. Okay. Here, this is the omega c. Omega c is the carrier wave frequency, and omega c minus omega m will be lower band frequency. Lower band frequency. Omega c plus omega m will be higher band frequency. Higher band frequency. See, in this case, this will be the uh, message wave frequency. That will be omega m. Omega e, we can say omega m or omega e, we can say here. Now, this will be the omega m and omega c. I can write there. This is the omega m plus omega c. This is the omega c minus omega m. This will be the lower band. Okay. This will be higher band frequency. Okay. Or sometime it is also called lower band side LBS and higher band side. Okay. Now you can see here the bandwidth will be, I can write this is the omega 2, this is the omega 1. Then the bandwidth will be omega 2 minus omega 1. Omega 2 minus, that will be omega 1. This will be the bandwidth, 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 bandwidth. Now, in terms of frequency only, this will be equal to f2 minus f. Okay. In frequency term also, the modulation index can also be written as delta f over f, the message wave frequency of the carrier wave. This is the, here you will get carrier wave frequency, not a message. This is equal to the modulation index also. By using this formula, we can solve all the problem that is asked in our exam. Okay. So take a screenshot of this expression also. Okay. And you, when you solve this, then you will get this bandwidth frequency will be equal to omega 2 time of omega m, and here I will get 2 time of this SM, message wave frequency. Okay. So let's go for the amplitude case. In this case, this is the message signal, this is the carrier signal. In this case, the amplitude modulation signals we are getting as a result. Now, this is the message wave or modulated wave amplitude. Now, this is the interfered wave. Here you can see this is the minimum amplitude, and here you can see this will be the maximum amplitude. Okay. So the message wave amplitude can also be written as the A maximum, amplitude maximum, and this amplitude. Okay. This will be equal to K AM maximum of this AC, and this is the divided by 2. You can say for the carrier wave, what we will have, it is the sum of this A max and A minimum amplitude. That will be equal to 2. Then the modulation index can also be written in terms of this AM and AC. This will be equal to A max minus A minimum. This is A max plus A minimum. This is the formula used, and modulation index, we have another formula, DF over. These are the formula used for the modulation index. Okay. So write down this formula and take a screenshot of this also. Now we will discuss the problem based like PYQ problems correctly. Okay, is this clear to everyone? Is this clear? You can write in also chat box if you have any doubt. Okay, I most of are having the doubt cleared. Now see this question that is asked in your exam. TV transmission tower at particular station has height HT of 160 meter. What is the coverage range? First, you need to find the what will be the coverage range. By how much the height of tower be increased to double its cover range. Okay. Given the radius of the earth is 6400 kilometer. What is given? Radius of earth is given you as a 6400 kilometer. Okay. First solution. In solution, what is given you? The height of this tower for particular station is given as this 160 meter. First, we need to find the coverage range. How we can find? We already discussed the formula. That will be 2 times radius of earth and height of the this antenna of the power station. Now put the all the values in this equation. There will be 2 radius of the 6400 kilometer. For kilometer, I am taking it into meter by using the 10 to the power 3. R is given as 6400 kilometer. 1 kilometer equal to 10 to the power 3 or 1000 meter, I guess. Directly. And height is given as the 160 meter. Then this will be equal to uh, this will be equal to 2 into 6400. Then what it will be? 2 multiply 6400. Here are 20 and 30, and this is also one another. Then there will be 10 to the power 6 and multiply 16. Now you can see here, 2 multiply 64 multiply 16 and 10 to the power 60. 64 is the square root. What is the square? Square root of this, that will be 8. The square root of this 16. So I can write it 8 multiply 4 root 2 and power will be 10 to the power 3 meter. In terms of kilometer, what will be the range? 32 root 2 kilometer. This is the range of this signal. Okay. Is this clear? Okay, those who are late, you can see the replay of this class, na? Okay. So now, in second case, what it is asked? In second case, how much height of the tower to be increased to double its coverage? We already know the range is proportional to height. Now, if I'm taking this, if I want to change this height, if what will be height when this d prime is equal to twice of d? When this equal to twice of d, when I am having this d like d prime is proportional to here. If I am having 4 time of here, I can decode d square is proportional to this h height. D square will be proportional to this h height. If I am having this uh, if I am having this twice of d, then I need to change the height with multiple of this 4. Then to get the height as it d, I need to change the height of antenna with 4 time of initial height. Then the final height will be equal to twice of d, mean twice of d equal to 4 time of initial height. What is the initial height here? Initial height is 160 meter. Then this will be equal to 64 meter, 6640 meter. And what is the initial height? It is the 160. Then change or we need to increase 64 minus 160, that will be 480 meter, which means I need to increase the height of this tower. Initially it was 160 meter. Then I need to increase this height from here to here. That will be 480 meter. The answer will be 480 meter. I hope this is question is clear. ये क्वेश्चन क्लियर हुआ भाई? Okay, awesome, very good. Now see this question. This question is asked in your NEET exam. Range of the frequency allotted for the FM radio broadcast is. Which option will be correct? Write in chat box. See carefully. Okay, I am getting the responses. Very good. Awesome. Very good. Others? Respond here. Okay, I'm getting the responses. Very good. Awesome. Here you can see these two options in numerically like magnitude wise look same, but see the unit. We already discussed about the FM radio broadcasting need to be very high frequency. That will be in terms of megahertz, 88 to 108 megahertz. This option having kilowatt. That's why this incorrect. Here we are having only 8 to 88, but it is starting from 88. Then we can't say like these option will be correct. Because of that, only option A will be correct. Okay. Now see this question. This is the question as the same. We need to find its range. B equal to twice of this radius of this earth, that is terms of kilometer. Then this will be 10 to the power 3. And what will be height? Height is 500. After solving this, you will get answer as a 80 kilometer. Solve this. This is the same question as we discussed. Okay. Now take a screenshot of this question. Now, see this question. This is the question that is asked. See, I taken all the questions that is asked in your NEET exam, and like some of the question is also like another competitive exam that AIPMP, that was previously known as AIPMP. Now it's converted NEET. So this is a question. An oscillator is producing FM wave of frequency 2 kilohertz with a variation of 10 kilohertz. Variation is there, 10 kilohertz. Variation means bandwidth, and the frequency is given as a 2 kilohertz. In that case, what will be the modulation index? Can anyone tell what is the modulation index here? Which formula we need to use, frequency or the amplitude modulation? Okay, okay, very good, very good. Awesome. You are taking the class very attentively. That's why that is good. Now see here. Okay. So modulation index in terms of frequency bandwidth, that will be delta f over this f. This given frequency, applied frequency, carrier wave frequency, you can say here. So this frequency is given to you like variation frequency. First, we need to find what is the bandwidth variation frequency here. The variation frequency is 10 and the wave frequency is 2. Then the modulation index will be 5. Okay, 5 will be the modulation index. Okay, okay. Now see this question. Modulation frequency is 5 kilohertz and the carrier wave frequency is 100 kilohertz. Then what will be the bandwidth of AM transmission? What will be the bandwidth there? Tell me, what will be the bandwidth? How we can find the bandwidth? See, here we need to use the expression as bandwidth, and here given is the frequency. Then the delta f will be equal to f2 minus f1. F1 or directly I already told you like this is the twice of multiple this fm. If If you are not able to find what is the FM here, then use this formula. What was the formula? M plus, here the frequency only. So we need to write the frequency only here. Then the FM plus FC minus FM minus FC. These things we need to use here. Sorry, FC minus FM. Then this is a twice of FM. Then FM is here 5 kilohertz. Then the bandwidth frequency will be twice of this 5 kilohertz. That will be equal to 10 kilohertz. Okay. This is the bandwidth frequency of the amplitude modulated transmission. Okay. Now see this question. See this question and try to tell me what will be the answer. See this question carefully. In this question, it is given the carrier frequency of the transmitter is provided by a circuit, tank circuit, a coil which having inductance 49 microhertz, capacitance as 2.5 nanofarad, and the audio signal of 12 kilowatts, it is modulated. It is given as modulated by this audio signal. Okay. The frequency range occupied by a side band. Okay. We need to use the sideband frequency range. Mean what will be the range of this? You can say bandwidth. You can also say like lower sideband and the upper sideband. We need to find that also. Now here it is the inductance, and here it is the capacitance. Then what will be frequency of this LC circuit? LC circuit having 2 pi square root of this 2 pi square root of this 1 over LC. Okay, we are having this frequency. Then 1 over 2 pi. What is the L here? L is 49 micro Henry. That is the 49 micro means 10 to the power minus 6. And this 2.9, so 2.5 nanofarad, that will be 10 to the power minus 9 nanometer. I can convert this 2 pi, and this is can be converted into 49 into, if I'm having this point here, then what I need to do, I need to put a 10 to the power minus 10. Then this will be equal to 25, 10 to the power minus 10. Take the square root of this. Then what it will be? 1 over 2 pi multiply 7 multiply 5. And here we are having minus 10 here. Then what it will be? Minus 10 square root of minus 5. And this 10 to the power minus 5 when goes up, then it will get 10 to the power plus 5. Okay. Solve this 1 over like 75, like 7 multiply 5, 45, and 9, 3, 35, and twice 75. When you solve this, then you will get answer as the 40. You will get answer as a 42 point something and kilowatts. Okay, now what we need to do here, we need to find this also 12 kilohertz. Here you are having 12 kilohertz, then the sideband frequency will be equal to, you will get here like this is the omega m, you can say omega m, the message signal. Now omega m plus omega c. So we can say range will be equal to this 42 point something plus this is 12 kilohertz, and this is equal to approximately 64. So, 1 minute, I need to check this first. Wait. Okay, solve this one. Here I will get 1 over 70 multiplied 22 multiply 7. And this is 10 to the power 5. Okay. Now see here 7. So this will be equal to 1 over 4, 4. Let's see. This is equal to 154 and 10 to the power 4. Wait, wait. Maybe I taken wrongly here. Wait a minute. 1 by 70. That will be, if I'm putting the value of pi here, then 70 multiplied 22 and 7 will be denominator. 7 will comes up 10 to the power 5, 7. There will be 10. Then I will get it here. And 110, I can cancel out 10 to the power 4 and 22 in denominator. This is the frequency of this LC circuit. When I having the this, when I solve this expression, then I will get, this is the 1 over 22 into 10 to the power 4 in terms of this kilohertz. Sorry, not kilohertz. It is only right now in hertz. Okay. So when you solve this and when you add this carrier wave frequency in terms of kilohertz, then you will get this range, because we are getting answer as about 400 range. Then if I'm adding 12, then this will be equal to approximate 66. Okay. So this will be the correct option for this question. You can check the calculation here. Okay. The answer will be B for this option. Now see this question. What will be the answer of this question? In this question, it is given as a carrier wave of peak voltage 14 is you transmitting a message signal. The peak voltage of the modulating given is modulation index is 80%. Modulation is index is given as the 80%. Mean 80 by 100. And this is equal to peak voltage, carrier wave peak voltage. Carrier wave peak voltage. And I already know AM by this, what? This code AC. AM I need to find. AM I need to find. It is given in volts, so no issue. There will be 14. Then what will be AM here? AM will be equal to 80 by 100 multiply 14. Then 1 0 will cancel out here. Okay. When you solve this, 12 division 10, then the answer will be 11.2. This will be the correct answer. Okay. Now this is the last question of this class. The number of amplitude modulation broadcast station that can be accommodated in 300 kilohertz band width of the highest modulating frequency. See, in this question, what we need to do here, we need to find the number of amplitude modulated broadcast station. For this case, there is a like total. This will be total frequency, or you can say total accommodative frequency, and there will be the twice of modulated frequency. Can I write also? This is the total F, Ft, and this will be twice of modulated. And here is the total F is equal to 300 kilohertz, and the twice multiply. This is equal to 15 kilohertz. Then the answer will be, if I take this 15 to the 30, then the answer will be 10. So write this formula. Number of like antennas, you can say number of antenna, and the number of amplitude modulated broadcast station, that will be the same. You can write the formula here. This is equal to the total frequency of the produced by the all the stations and the modulated wave frequency. Okay, this will be the final of this question. Now, if you have any doubt, then let me know. Any doubt? No? Thank you, everyone. I hope you learned a lot from this class. So we will meet you in next. Okay, bye bye. Take care.